Good morning, everyone. My name is Harsh Kumar. I am pursuing Bachelor of Technology in Electronics and Communication Engineering, Internet of Things branch from Madan Malvi University of Technology, Gorakhpur. I am going to present my project on smart home automation, a system designed to make our homes more intelligent, efficient, and secure. In today's fast-paced world, automation has become an essential part of modern living. Smart home automation integrates IoT technologies to allow users to monitor and control home appliances remotely using smartphone and cloud platforms. So this project aims to integrate the concepts of embedded system and IoT to create an intelligent home environment where appliances such as fan, pumps, sensors can be monitored and controlled remotely through our smartphone using the Blink Cloud platform. Through this internship, I gained hands-on experience in microcontroller programming, sensor interfacing, and cloud connectivity applying theoretical knowledge to the real-world IoT application. The system not only enhances comfort and convenience, but also focuses on energy and efficiency, safety, and smart monitoring, reflecting the core objectives of the immersive embedded learning approach. So here the contents in which I will discuss are the C programming, the C++ programming, embedded system, Internet of Things, learning outcomes, smart home automation, components, simulation, advantages, application, conclusion. Then C programming. Then the is a foundation language for system level programming. Key topics are the loops, functions, pointers, arrays. So C is a structure and procedural language model developed by Dennis Ritchie. It is known as the mother of all modern languages because C++ and many other like Java, Python, and C are derived from it. C is used in system programming, embedded system, and compilers and operating system like Unix. Features of C are simple and efficient. It is portable. Code can be run on any machine with a little modification. It is a structured language. Programs are divided into functions, disk library, built-in functions for input, output, and math. Low-level access can directly interact with hardware and fast execution. So the applications and internships are writing low-level code for microcontroller and understanding the logic for embedded system. Here, the here are the data types that are used in C language. That is integer, float, character, double, and void. They are variables and constant. Variables are names, memory location used to store data and a constant value that cannot be changed. And there are operators, arithmetic, relational, logical, assignment, and increment, decrement, and loops, if else, switch, case, loops, and functions, and arrays, and strings, pointers, structures, file handling. These are used in the C program. Advantages of C are fast and efficient, portable and powerful, easy to learn, structured and modernized, foundation of for the advanced language. Applications of C are operating system, embedded system, compilers, interpreters, database system, and IoT and microcontroller projects. Then move to C++ programming. So C++ programming is an object-oriented programming language developed by Ballerine, Struck, and Bell Labs. It is extension of C language that includes features like classes, inheritance, polymorphism, encapsulation, abstraction. It supports both procedural and object-oriented programming. The basic structure of C++ are database because the data and variables are used in it, integer, float, character, double, and boolean. Operators are arithmetic, relational, logical, assignment, increment, decrement. The control statements, tuples, switch case, loops, functions, and then arrays, strings are used, and object-oriented program concept like is a object encapsulation, inheritance, polymorphism, abstractions that are used in C++ programming. It is used in modular firmware design and simulation. Then move to the embedded system. Embedded system is a combination of hardware and software for dedicated tasks. It typically consists of microcontroller or microprocessor, input or output interfaces, and control software written in C, C++. Examples include smart home devices, transponders, and industrial home automation. In this project, the microcontroller acts as a central processing unit that reads data from sensors, processes it, and sends control signals to actuators and output devices. Then the rules of then the Internet of Things. The Internet of Things connect physical connected devices to Internet, allowing real-time monitoring, control through cloud platforms. IoT enables users to collect data, analyze experiments, remotely operate devices from a smartphone and or computers. So in this project, we used Wi-Fi module ESP8266 is used to connect a system to Blink Cloud. Real-time sensor data, temperature, motion is included to the cloud. The user can control appliances like fans, LEDs, and displays directly from Blink mobile app. The protocol that are used in Internet of Things are MQTT, HTTP, Wi-Fi, and Bluetooth. There are some other protocols also. The projects are the examples of Internet of Things are smart home, remote monitoring system, and automation. The IoT tools and technologies are hardware, that is Arduino, ASP32, Raspberry Pi, and in the software, that is Blink, ThingSpeak, NodeMCU, Arduino IDE. The cloud that are used in IoT tools and technologies are data visualization and control, hands-on IoT prototype and development. The Pixel Lab is a powerful microcontroller simulation tool that helps in designing and testing embedded systems without physical hardware. It supports microcontroller like PIC 16F8778, 80 mega, 3 to 8 pin that is Arduino, and peripheral devices like LCDs, LEDs, temperature sensors, LM35, and keypads. It is used to test embedded code virtually. In this project, the system was simulated in PixelLab using Arduino Uno board. Components are LM35, 16 cross to LCD, RGB LED, LCD, RGB LED, Wi-Fi module, ESP8266 were virtually connected. The system successfully displayed temperature readings on the LCD, controlled LEDs to the blink app, demonstrating a complete IoT-based smart home model. It is helped to learn embedded concepts safely and efficiently. The learning outcomes that are learned from this internship are gain coding and debugging skills, develop IoT projects, understand microcontroller interfacing, and improve technical and analytical thinking. Then we come to our project that is smart home automation. Smart home automation monitoring system is designed using Arduino UNO LM35 temperature sensor and an LCD display that is HD44780. The system continuously measures embedded temperatures and displays the readings on the LCD screen. An RGB LED is used to visually indicate temperature levels, blue for low, green for moderate, and red for high temperature ranges. The introduction that includes this project focuses on developing smart temperature monitoring control system using Arduino. It integrates various components like NM45 temperature sensor, extreme close to LCD display, RGB LED, LED matrix, Blink IoT platform. The system continuously senses temperature, displays data on an LCD, provides remote access via the Blink mobile app. The objective of this project is to measure real-time temperature using LM35 sensor to display temperature and status information on an LCD module to indicate temperature range through a RGB LED color codes to provide visual alerts to an LED matrix to enable wireless monitoring and control via the Blink IoT app. The components that are used in this project are Arduino UNO microcontroller board that process input and controls the output, NR35 sensor analog temperature sensor providing 10 millivolt per degree Celsius output, 16 cross to LCD HD44780 displays temperature and system status. RGB LED provides visual indication based on the temperature levels. LED matrix displays patterns or alerts. Blink app enables IoT based remote monitoring and control system. The working principle of this project is the LM35 sensor measures embedded temperature and sends analog data to Arduino. Arduino converts this data into a readable temperature value and displays it on the LCD. Depending on the temperature range, the RGB LED change color: blue for cool temperature, green for normal temperature, and red for hot temperature. Simultaneously, data is sent to Blink app through an IoT connection and wireless monitoring. Then the circuit description that is used the sensor output is connected to analog input pin A0 of Arduino. The LCD operates in 4-bit mode using the digital pin D2 to D7. RGB LED and LED matrix are connected to PWM pins to control color and patterns. The ESP8266 Wi-Fi module connects to Arduino serially to send data to the Blink Cloud platform. These are the circuit description, then software circuit simulation, the Arduino ID used for writing and importing the program code. The program code is we have to write in Arduino ID, then it is used in PixelLab. In PixelLab, that is version 0.9.2, used to simulate circuits, connections, and test the project virtually. Blink platform configured for IoT connectivity and remote visualization. Simulation helps to validate hardware performance before physical implementation. Here, the code is written in Arduino IDE, then it is uploaded in Exmertz. And first we open Exmertz, then Arduino UNO, then the load text code it is used in Arduino IDE. So here are the steps. Here is the code explanation overview. Is the initialization of LCD sensor, then RGB LED, reading analog input from LM35 and converting to the temperature. Reading the analog input from the LM35 and converting to temperature. displaying temperature and messages on LCD, applying condition statement for RGB LED current logic, sending sensor data to bring out for IoT access, after controlling LEDs remotely via the app. The advantages of this project is for convenience and automation, energy efficiency, enhanced security, remote monitoring and control, data analytics and insights, scalability and flexibility, improved property value. The applications of this project are healthcare and pharmaceutical, food and beverage industry, cloud chain logistics, manufacturing and industry, and data center. Here are the applications of the IoT. The final conclusion, the system successfully demonstrates temperature sensor displaying and controlling using Arduino and IoT enhances environmental monitoring, automation, and remote access. So here it is final discussion of this project. So thank you.
Hello, here can see you the project code that I built in this internship. Here are the files with LDR CPP, LDR header files. That is that is a preprocessor as we seen in the learnings. Then we are moving towards the implementation. As I fill the hex file on this, and then I get the interface about the home automation on a blink, and then I can handle this remotely, as you can see. Here we can see if I click on the cooler button, then the cooler in the temperature system starts, and here we can see also the serial tank, that is a tank which shows us the value of water. Here I off the cooler button and start the heater button, then we can see the temperature sensor changes, and also if I start the outlet valve, then water will be consumed out, and as as the water level comes down to the 200 liters, then automatically inlet valve will be on and just start filling the tank. So I will off the outlet valve to fill the tank. And as you can see, here are we getting the notification about everything. The temperature is about 35 Celsius. So it automatically turn off the heater button. And as you can see, the inflow dis disabled. As we can see, the tank is full. So automatically the tank inlet valve will be off. And this is how can we save the water. Now moving to the last part of this, as we can see the conclusion. Using Blink IoT application and the Pixing Lab simulator, the simulated home automation where LED, temperature system, serial tank, heater, cooler, and water tank in real time. We can handle this thing in real time on using these apps, the Blink IoT app. And CLCD acts like a dashboard used for the displaying the event widgets from Blink IoT app like buttons, widgets, or the notification bar, or the temperature sensor, or the volume sensor, which shows us how much the value of current situation. Gauge widgets to display the temperature and volume, as you can see. So moving to the last part of this presentation, I will thank the Emergis technology to giving me the opportunity to work on this project, and also I'm looking forward to make this project in real time. This I done only in simulation manner. Thank you.